Okay, this is our final lesson for the year for Honors Pre-Algebra. So first of all, congratulations on making it this far. I know that this year has been tough and challenging in many ways, but I just want to take a minute to tell you how proud I am of each one of you and just the hard work that you've put in this year in rising above those challenges and really just excelling in every way. So congratulations, we are almost done. This is our last lesson, and in this lesson I really combined everything from your review to your quiz to your test. So you'll see all the material that will be covered, but it doesn't mean it's going to be on every assignment. It might be on the review practice but not on the quiz, or on the test but not on the quiz. But as long as you understand everything in this video, you'll be prepared for all three assignments coming up in big ideas. So the first thing we need to go over is just our quiz and test instructions, and this has not changed from the last test. You guys did a lot better on showing your work and sending it to me, so just basically do the exact same thing this time. If at all possible, when you hit that submit button on your test, send me your work right away. Okay, so I really, the part that makes things a lot more time consuming for me is when I have to reach out to you, email your parents trying to find your scratch work, because I cannot give you a grade until I have that scratch work. And so it's just really important. Again, you should not be receiving any outside help, parents, tutors, classmates, anybody at all on your quiz and your test. So it should just be you, as if we were in the classroom doing the quiz and test in the classroom setting. All right, so jumping right into the concepts. All right, now this all three of these assignments are a combination of everything you've learned in the fourth quarter since we've been doing the online learning. So you will see concepts from chapter 13, 14, and 15 in this review video. I've narrowed it down to the concepts that specifically will be in these assignments. Okay, so the first one is to find the slope of the line through the points. Well, if I'm given ordered pairs, actually, first of all, time out. If you can, you should have printed out your fill in the blank notes. I want you to, as much as you possibly can, pause the review video and work these problems before I work them. And then press play again on your YouTube video and then see if I explain it the way that you solved it. That's the absolute best way to get the most out of this review lesson. All right, so I want to use my formula, m equals y2 minus y1 over x2 minus x1. Okay, so our sequence up here hasn't changed. This is x1, y1, x2, y2. Okay, so my y2 value is 6 minus my y1 value. So a lot of times you're going to see those double negatives with slope. So just definitely don't miss that. Over 4 minus 6. Make sure you change that double negative to a positive, and you get 8 over negative 2. Well, if you put this answer into big ideas in your answer, they're going to say it's wrong because you didn't reduce it. Your slope is negative 4. Or you could say negative 4 over 1. On the next question, they want us to identify the slope and y-intercept. So if you remember, slope is m and y-intercept is b. Okay? So in order to determine that, I have to first make sure that my equation is in slope-intercept form. I can't say what they are unless it's in that format. So my first question is the equation in slope-intercept form? Okay, your answer is yes. All right, so now I know slope-intercept form, just as a review, is y equals mx plus b. So I'm looking for the value that occurs in these places in the formula. So my m comes before the x, m equals negative 2/3, and b equals negative 6. All right, and that's the slope and y-intercept. And again, if I'm showing you these questions, it's because you're going to see these types of questions on 1, 2, or maybe even all 3 of your big ideas assignments this week. All right, so now let's talk graphing. All right, so my graphs aren't going to be perfect by any means, but we'll get the point across, and we'll solve that way. All right, so graph y equals 3x minus 4, and then identify the x-intercept. Actually, real quick, I'm going to pause real quick and pop in some graphs onto this slide. That'll make it a little bit easier. All right, ta-da, it's magically there now. We'll use the same graph for both of these problems. Okay, so let's start off on the first one. It says graph y equals 3x minus 4 and identify the x-intercept. So on your assignments this week, you're not going to be asked, do a table or, anything like that. So really, it's just the 2 methods, and that's slope and y-intercept, which we're going to use that method here. Or here, it even hints at the method we're supposed to use, using intercepts, because this is not in slope-intercept form. So there's actually an easier method to use. So we'll review both. All right. This equation is already in slope-intercept form. So I literally can look at this equation and I know exactly how to graph it. My first point goes on my y-intercept, -4. So I come down here to a -4 and I plot my point. Okay, now from that point, I follow my slope. Well, there's only one number. Well, remember, it's rise over run. So I'm going to rise 3 and run 1. Okay, and now I'm going to draw my line as straight as I can through these points. Let me get it a little straighter. Straight enough. Okay, and I draw my line through the 2 points and I've graphed. So to identify the x-intercept, once you draw your line through the 2 points, you can see where the line would cross the x-axis. And the value where the line crosses the x-axis is your x-intercept. So x-intercept, and there will just be a blank, equals 1. Okay, so it'll give you a blank for the x-intercept and you would just put in a 1. Okay, that's a 1. All right, so now let's clear the screen and we will work on your second graph. All right, so 2x plus 3y equals 12. If it says using intercepts, it means that you're actually going to write your equation twice. You guys remember why we write it twice? Because on the first one, we'll solve for x, and on the second one, we'll solve for the y-intercept. Well, if I need the x, do you guys remember what you plug in for y? Plug in 0. Well, 3 times 0 makes it cancel. So now to solve for x, I get x equals 6. But remember, that's not just a number by itself. That means 6 is my x value when I plugged in 0 for y. Okay, so now let's do the second one. We're going to solve for y, so that means we plug in 0 for x. And now we just simply divide both sides by 3, and y equals 4. Well, we plugged in 0 for x, and 4 is our y value. So there's our 2 ordered pairs that we need to graph. We plot a point on an x value of 6 and a y value of 4. And we're all done. Okay, so now let's talk about slope-intercept form. Now remember, slope-intercept form, this is our baseline. Okay, this is our format that we're going to follow. So let's answer these questions. It says write 2x minus y equals 4/5 in slope-intercept form. So obviously our goal is to get y by itself, then my x, then my b. Okay, all right, so let's start moving these terms around. we have 2x minus y equals 4/5. So what we'll do first is we'll subtract 2x to the other side. But if you remember back to this lesson, these are not like terms. I can't just subtract them from each other. So again, I'm using the slope-intercept formula as my basis, and I get negative y equals negative 2x, and because there's no sign in front of 4/5, I know it's positive 4/5. Okay, but now we have this negative out in front of the y. Okay, and that's a problem because y is not negative in our formula. Okay, or remember, if there's nothing in front of the y, it means that there's a negative 1, an understood 1. So now you have to divide everything by negative 1. And basically what's happening now is you're reversing the signs of your other terms. So now you do have y equals positive 2x minus 4/5. And you have it in slope-intercept. Okay, so now, let me pause real quick because we're missing some information on this one. Now we'll write our equation. I think I'm missing a graph here. Okay, that makes a lot more sense now. So we were missing that graph. And of course, I'll make sure it's in your notes. So anyway, okay, here's our graph, and we need to write an equation in slope-intercept form that passes through these points. So from a graph, I need two pieces of information. I need my slope, and I need my y-intercept. So if I have a graph, I could count rise over run, 1, 2, over 1. For my slope, y equals 2 over 1, or just 2x. And then for my y-intercept, or for my b, I just have to make sure I identify the value that the line crosses the y-axis. So because it crosses at a positive 2, I will say plus 2. If it crossed at a negative value, I would say minus whatever value it crossed at. All right, so you'll have a question like that on your assignments this week also. Okay, so now let's talk point slope form. You will have to have this formula memorized. All right, so we have y minus y1 equals m times x minus x1. All right, and we'll use that formula to answer these questions. The first one says, write the equation in point slope form of the line that passes through the point 1, 4 with a slope of negative 3/4. So point slope form is just simple substitution into this formula, okay? The reason it gives me an ordered pair is because I need an x1 and a y1 value to plug in where they go in the formula. So we say y minus my y1 value of 4 equals m, that's my slope, times x minus my x1 value, which was 1. And this is all you have to do to write an equation in point slope form. All you're doing is plugging it in. So it'll be really important when you're reading these questions, you need to look. Is it calling for point slope, or is it calling for slope intercept? Point slope means just plug in the numbers. Slope intercept means we plug in the numbers, but then we have to keep solving. All right, and that's what we see. I'm going to clear the screen so I have more room to work, but that's what we see on the next problem. It says, write an equation in slope intercept form of the line that passes through these points. Well, in order to do slope intercept, I need a slope and I need a y-intercept. Well, we always start with slope. M equals y2 minus y1 over x2 minus x1. y2 is 2 minus 10 over negative 4 minus 6. All right, so I'm just using these ordered pairs and my sequence. So I get negative 8 over negative 10. which is 4/5. All right. So now this is the point where I come back up here to my ordered pairs. Does either ordered pair tell me the y-intercept? Does either one of them have an x value of 0 and then a y value? The answer is no, so that's why I have to use point slope form now. I can choose. It does not matter which ordered pair I choose. I can choose one or the other, but I'm going to choose one to be my x1, y1 for point slope form. So we have y minus y1 equals slope, m, 4/5, times x minus x1. All right. Okay. So y minus 10 equals 4/5 x. Now, I'll just say on your assignments, this is going to work out a lot better than what it's working out here, just because I made up the problem. So don't worry, don't think, oh my goodness, my y-intercept is going to look weird. Okay, so this is going to be negative 24/5. And again, that's normally a whole number. I was off by 1, but it doesn't change the way that we solve. All right, so our last step is to get y by itself over here. So we just need to add 10 over here, and we would add 10 to the like term. Okay, so we get y equals 4/5 x. Probably the easiest thing to do, because we're dealing with this fraction, is just to change this to a decimal. We'll do that by dividing 24 divided by 5, okay? And that makes this negative 4.8. So now we can add these together. Now, again, don't worry about this being a decimal. It will not be a decimal on your Big Ideas assignments, okay? But we're just kind of following the steps of writing this in slope-intercept form. So we would do our distributive property here, normally as a whole number, and then we would just add 10 to both sides. Okay, so that's slope-intercept. Okay, exponent. So we have a lot packed into this slide, but basically I just took the questions from your assignments and I tried to make very similar questions. All right, so a lot of these will come down to not really showing a whole lot of work. So just remember, on your quiz and your test, write down the original problem and then box your answer. Do not skip problems in your work that did not require work. I still need you to write down the original problem and your answer, because your quiz and your test are scrambled. Not everybody sees the same questions in the same order. So, and that's just kind of to help with some of the integrity of the test. So I have to see your original problems, okay? Remember, when it's power of powers, one base raised to a power, raised to another power, it's multiplication. Don't have to show any work here. Just do the multiplication. When it's product of powers, meaning you have exponents with the same base being multiplied. Do you guys remember what to do to the exponents? You add them. Keep the base in parentheses and add your exponents. Now, when it's multiple terms, this is a times b raised to a power. Please don't forget, you're raising each term to that power. You have a problem like this coming up. A to the 5th, b to the 5th. Raise each term to that power. Over here on the right-hand side, we have some simplifying to do. Okay, so we have pi to the 15th power. Just because it's pi doesn't mean we treat it any different. Pi to the 15th power over pi to the 12th power, because this was multiplication. Now I can do my quotient of powers, my subtraction, to get pi to the 3rd power. All right, all of this will be on your Big Ideas assignments this week. Now, on the last one, I have g to the 12th. I need to do my product of powers, and I get, ironically, g to the 12th. So does that mean that this reduces to 0? I don't know. Okay, so this one gets a little weird because I have to do 12 minus 12. What is 12 minus 12? 12 minus 12 is 0, right? So this is g to the power of 0. Do you guys remember what happens when you raise a term to the power of 0? It's 1. So your answer is 1. Your answer is not g. It's 1. Okay, let's talk negative exponents. Now, be careful to read the directions. This one says evaluate, which means you are actually evaluating the power, but you cannot evaluate a negative exponent. All right? So when I see 4 to the negative second power, do you remember my rule to change a negative exponent into a positive exponent? All right? My rule says to put it into a fraction, and then if it's in the top part of the fraction, you can move it to the bottom part of the fraction to make it positive. You flip it into the opposite side of the fraction. Now you can evaluate the exponent. 1 over 16. Okay, now we have 5 to the third over 5 to the fifth. Now, you can do 5 times 5 times 5 on the top and then 5 times on the bottom, and you get these massive numbers, and you try to reduce it. Well, instead of doing all that, do your quotient of powers, and you get 5 to the 3 minus 5. You got to do subtraction. So you get 5 to the negative second power. Well, now I'm in the same situation I was in my first problem. I need to flip it to the other side of the fraction. So now I can evaluate and say 1 over 25. So that made it way easier than trying to do 5 times 5 times 5 and do all the division and reducing. All right, let's look at this last problem. We see common base and exponent. So no problem. I'm going to add my exponents together. Negative 3 plus negative 2 is negative 5. But I can't evaluate negative 5. So I have to flip it. Okay. So 2 times 2 times 2. We know that one's 8. 8 times 2 is 16. 16 times 2 is 32. All right, so we do that multiplication to find 1 over 32. So you can see here on the negative exponents, I definitely had work to show. All right, there was definitely some work that I needed to show here. On the last slide for product of powers, there wasn't a lot of work to show, and that's okay. But remember, do not skip a problem just because there's no work to show. You still write the original problem and the answer. Okay, so now let's look at these directions. It doesn't say evaluate, it just says write your answer using positive exponents. So it's fine to have an exponent in my answer. On this first problem, okay, I don't really like the dot being there, but it will be there in big ideas. I want you to understand this is like 7 to the negative fourth, x to the fifth, okay? Because when numbers and variables are together, that means multiplication. So let me ask you this. Is there anything wrong or anything needing to be changed with x to the fifth power? No, because it's already a positive exponent. So what you need to remember is you don't have to move the entire term to the other side. X to the fifth can stay right where it is because it's already positive. The only part you have to move is the part that had the negative exponent. X to the fifth over 7 to the fourth power. And all you're doing is moving these terms to the other side of the fraction. All right, let's look at the last one. Now we have coefficients. Well, can we do 10 divided by 5? Absolutely. Okay, can I do my subtraction here? Absolutely. So let's simplify this. We have 2y to the fifth power minus 9. I'm just doing 5 minus 9. I'm doing my quotient of powers. So that's 2y to the negative fourth power. So now I have the question again. I can't have a negative exponent in my answer But do I need to do anything to the 2? Does the 2 have a negative exponent? It doesn't. It has an understood 1 because there's nothing there. So the 2 can stay right where it is. The 2 doesn't move. Only the y moves to make it positive. All right, so just make sure you do that on your big ideas assignments. Okay, scientific notation. We are starting to near the end of this. Write the number in scientific notation. So I need a number greater than 1 and less than 10. That decimal value will always come after the first number that is not 0. Times 10, and I count my place values. 3, 6, 9. 10 to the 9th power. Simple enough. I do need to give you one that would be negative. What if I had 0.00, and again, I'll make sure this is in your notes, 234. Okay, well, it doesn't change the fact that I still need to move my decimal after the first number that's not 0. So it'll be 2.34, still times 10, 2, 4, to the negative 5th power. So again, you might see the positive version on your homework, but then you'll see the negative version on a quiz or a test. So you could see both ways. For standard form, we look at that exponent. If it's positive, I know I'm making my number bigger. If it's negative, I'm making my number smaller or moving my decimal left. So because I'm making it bigger, my decimal was here, I go out 6 places. 3, 6, so that means 6 zeros. 1, 2, 3, 4, 5, 6. And then go back and put in my commas. So on the flip side, if I gave you 3.2 times 10 to the negative 4th power, now you need to make this number a lot smaller, so you're moving your decimal left 4 places. Well, you already have 1, so how many more zeros would you need? 3 more zeros. 1, 2, 3, and then your numbers. All right, and that's standard form. So at any point, if I'm going too fast or you need to catch up, remember, you just hit that pause button and catch up on your notes, and then you can play it whenever you're comfortable. It's just a lot of material for this final lesson. So now we have operations. Okay, remember, with addition and subtraction, you've got to have the common exponents. If you have a common exponent, it's a piece of cake. Okay, so the operation shows here, subtraction. So now all I have to do is subtract my numbers. 5.44 minus 3.22. And I get 2.22. And then I just bring down my common exponent. Doesn't matter that it's negative, I leave it negative. All right, but now let's look at the addition problem. Do I have same exponent? No, I don't. So remember what I told you. You need to move, or you need to change which one. You need to change the one with the smaller exponent to raise it up. So how many would you add to 2 to make it 3? 1. So my rule says if I need to add 1, I move my decimal left that many places. I would strongly encourage you to rewrite this. 0.232 times 10 to the 3rd. So now I have my common exponents. And now all I have to do is add these together. Well, that's easy because this is in the ones place. I'm basically just combining them together. 3.232 times 10 to the 3rd. And again, at any point, if you can pause this and work the problems ahead of me, that can help you quite a bit. All right, so now let's look at these problems. We see numbers and then being multiplied by a power of 10. So multiply your numbers first. 7 times 4 is 28. And then bring down your 10 to the 5th because there was nothing to combine with 10 to the 5th. All right, but here's the problem. You put this answer in Big Ideas, and Big Ideas is going to say it's wrong. Why? Because this number's too big. So when you move your decimal left, what happens to your exponent? It bumps it up. So now your answer is 2.8 times 10 to the 6th power. Okay, and that's your answer. So don't forget, especially with multiplication, 9 times out of 10, that number is going to be too big. So on the division problem, same thing here. I don't have anything to combine with my powers of 10. If I did, I would just do my product of powers. So 3.2 divided by 4. I won't require you to show work on that division. You can use your calculator. You get 0.8 times 10 to the negative third. Well, you put that into Big Ideas, and your answer is going to be wrong because this number is too small. You need to move your decimal to the right now, one place. Well, if you move it left and it raises your exponent value, when you move it right, it lowers your exponent value by that many places. So your answer is 8 times 10 to the negative fourth. All right, I'm definitely going to be looking to give you partial credit if you were to get this answer, but then forget to bump your decimal. Okay, but this is your full credit answer. So that might be one you want to just rewatch real quick before you take your quiz or your test. Okay, finally, 2 more slides. Square roots and cube roots. Okay, so what are the 2 square roots of 36? Remember, there's no radical, so it's going to be a positive negative 6. And there will be 2 blanks usually on the Big Ideas answers. So now on evaluate the expression here, okay, you're going to see those shortcuts pop up again. Okay, taking the square root and squaring the same number, those are inverse operations. They cancel. So now it's 40 minus 169. So don't be thrown off and think, oh, this is going to be 40 minus 13. No, those inverse operations cancel out. So it's 40 minus 169. Again, you don't have to show your hand, subtraction or anything like that. You can use your calculator. Negative 129. All right, but this step I would want to, see again, original problem, show your work if you have any, and then box your answer. Okay, so solve equation. Remember, we always take the square root last. We would divide by 3 first. X squared equals 100, and that works out nicely, right? We can take the square root, but one thing I want to remind you of, when I take the square root, but it was not originally in the problem, remember, positive and negative 10 could be your answer. Okay, now we come down to this big old number, this huge number. Okay, and I'm going to say what I said in the lesson. Cube root of 4,096, you're going to have a way that you can do this by hand. Okay, because of those dual enrollment tests not having calculators, the absolute easiest way is to do upside down division. All right, so I'm just going to come up here into this blank space, 4,096. Okay, and this is something I'm going to be lenient on if we were in person, okay? If we were taking this test in the classroom, I would make you show the upside down division. It's difficult when you're taking a test online because sometimes you can have the square root and cube root memorized and you wouldn't need to show work. I will allow you to use your calculator to find cube root. I'm not going to question you on that. However, I'm going to do it here because you will have to know how to do it by hand next year. All right? Because in the classroom, we don't allow calculators on square root and cube root. All right? So here we go. We actually don't need the negative when we're doing our upside down division. 2,048, 1,024, 512, 512 divided by 2, 256. Numbers are getting smaller and smaller. 128. It is literally a ton of twos. A story of the twos, if you will. All right, 2 and 2 more twos. Okay, whew, that was a lot of twos, wasn't it? Okay, so now because it was cubed root, I would go 1 group, 2 groups, 3 groups, and 4 groups. So 2 times 2 times 2 times 2 is 16. All right, so I know you're like, oh my goodness, that is so tedious. Like, why do I have to do that? But again, you have to have, negative. It's got to be negative because it was the negative cube root. You have to have a tool or a method to do this by hand. So 36 plus negative 16, because it was negative, gives me 20. Okay, so that would be the strategy I would use. Again, I'm not going to take off on your quiz and test if you don't show the upside down division. I will allow a calculator. However, keep in mind, calculators are not normally allowed. Okay, Pythagorean Theorem. Find the missing dimension. You have to decide, is A, B, or C the missing dimension? Okay, it's the same formula, no matter what. The main thing is you have to get C in the correct location. C is always the longest side across from the right angle. Okay, so that would be 4. Okay, doesn't matter. These two are interchangeable. They connect to form the right angle. 2.4 squared plus b squared. Again, calculators are fine, so you can do 2.4 times 2.4, 5.76 plus b squared equals 16. Subtract 5.76 from both sides, and you get 10.24. b squared equals 10.24. You're not done though. You have to take the square root. Because it's a dimension, it won't be negative because you can't have a negative measurement. So b equals 3.2. All right, just using Pythagorean theorem to solve. So we're going to do the exact same thing on this next problem, and this is our last problem. All right, what is x? Is it A, B, or C? You say, well, what in the world? It's on the other side of the triangle. Well, or I guess it's a prism. But whatever x is here, it's going to be the same thing over here. So technically, it is connected. Okay, is that A, B, or C? It's my C, right? Because it's across from the right angle. So we're going to say 9 squared plus 12 squared equals x squared. I'm fine if you start off with the substitutions, but I have to see this work in your work when you submit it. So 81 plus 144 equals x squared. I add 81 plus 144, and I get 225. So nice how that works out sometimes, because when I take the square root of 225, I get 15. So x equals 15 yards on this problem. All right. So again, just to kind of wrap things up here, I believe that was the last problem. Yep. You might not see every single question. I mean, we just went through a half an hour of questions, okay? So your review assignment is longer than your quiz. I think your quiz is only about 15 questions. Your test is longer than your quiz. So you're going to see these questions on 1, 2, maybe all 3 assignments, all right? But I tried to cover everything you would see. So since this is our last lesson, I'll say it again. I love you guys. I miss you. I wish that the school year had not ended this way, but I just want to tell you that I'm really proud of you, and it's really been a pleasure and a joy to teach you. So I hope you guys have a great summer. Finish these last 3 assignments strong, and we're almost there, almost to the finish line.